Hey there everybody, in this video we're going to continue on our adventure of graphing sine and cosine curves. This time we're going to add in some vertical shifts and maybe some reflections. Oh boy. So let's take a look at the answers to yesterday's worksheet in case you need to see this for your reference. So feel free to take a picture, screenshot, do what you got to do. And the backside. And let's get into the new stuff. All right. So what we're going to do now is start tacking on d values for our sine and cosine functions. So we're going to be adding numbers or subtracting numbers at the very end. Just like we've seen in other function transformations, these d values are just going to move our graph up or down. So it's going to shift everything up or down. If it's a plus, it goes up. If it's a down, it's a minus. A value is still amplitude, and here we have the absolute value signs around it, or the magnitude, and that's because amplitude is always a positive value. The period of the function is still going to be using the b value, so 2 pi divided by the b value, and then our reflections will happen if we have a negative sign, what you would think is a negative amplitude. The amplitude is still positive, but the graph gets flipped upside down. Now what that looks like is if you have a sine curve, for instance. Sine curve normally looks like that. If we flip it, now it's going to go down first instead of up. All right, so first graph is a sine curve, second graph is a negative sine curve. Cosine, very similar. Positive cosine starts at the top. Negative cosine, you guessed it, starts at the bottom. So that's just the very basic shapes there. Okay, here we go. So when we go through these, I like to identify all of my important stuff first, and then I will create my y-axis. Once I have my y-axis, I'll figure out what's going on with my x. So let's get the y-axis first. All right, I've got amplitude is 4. The period is going to be 2 pi divided by 2. aka pi. My interval is going to be that period value, but divided by 4, because there's going to be 4 increments. So it's just pi over 4. And then shifts, we went up 3. Now, this shift is also going to tell me my midline is also at y equals 3. All right. So I'm going to plot my midline, 3. I'm then going to use my amplitude to go up 4 and then down 4. That's going to put me at 7 up top and down below at -1. My y-axis is now built. Now I'm going to throw in my x-axis. My x-axis has a value of 0, so it would be right about here. So I'll throw an x-axis across, shazam. At the end of my x-axis, I'm going to throw a tick mark to represent the period here. We already know the period was pi. I'm then going to take that and chop it in half with another tick mark, and then I'll chop each half in half. This is where our intervals come into play. We're going to count up by pi over 4. So I've got 1 pi over 4, 2 pi over 4, and 3 pi over 4. Of course, we'd go through and simplify, and I'm saying 2 pi over 4. All right, I'm going to call that pi over 2, pi halves. All right, all that's left is to get graphing. I like to sketch in going across my max, my mid, and my min lines. We have a cosine function. So it's going to start up at the top, come through the middle, down to the bottom line, back to the middle, back up to the top. So we start at the top line, go to the middle line, all the way down to the bottom line. Big mistake. Some people will put it on the axis. It's not necessarily on the axis. It'll be whatever your minimum value was. Back up through the middle and end at the top. Our graph looks something like that. I suppose I should have used a different color. Something like that. There we go. Try to avoid sharp corners. I realize I'm not setting the best example in the world there. All right, number 2. Identify the amplitude, period, any transformations of the function. All right, my amplitude was 2. The period comes from the b value. So I have 2 pi divided by 4 pi. Pi's cancel. 2 over 4 is 1/2. The interval is 1/2 divided by 4. Well, since 1/2 is a fraction already, I'm going to actually multiply it by 1/4. That's going to give me 1/8. Shifts, this thing goes down 5. So my midline is y equals -5. I'm also noticing that we are going to have a reflection. So typically my sine functions start at the origin, go up, and kind of swoop back down. This one is going to be upside down. So this one is going to look like the green function, since it got flipped. Everything else will be the exact same. All right, let me get our y-axis ready. I'll start off with my midline. We're at -5. From there, we go up and down 2 units, because that's our amplitude. And that puts us at -3 and at -7. Which then means my x-axis would be somewhere up here. The reason why I always have to know where my x-axis goes is that's where the labelings go. We put our little tick marks and labelings on the x-axis. We don't put them on the little boundary lines. We always put them on the x-axis. All right, the period of our function was 1/2. So I'll throw a tick mark down at the end. That was 1/2. I'll chop that in half, chop each half in half. My interval was 1/8. That's what I count up by. So denominators are 8. Numerators count up by 1s. So we have 1/8, 2/8, 3/8, 4/8. 1/8 does not reduce. 2/8, that's actually 1/4. So let's call that 1/4. 3/8 does not reduce, and 4/8, well, we already know that that's 1/2. All right, now I'm going to go ahead and sketch in my little boundary lines. The max, midline, the min, and I want to put this green shape, so we start at the middle, down to the bottom, to the middle, top, middle. I want to put that on my little sketch. So we start at the middle. The next step out, we'll go down to the bottom, back to the middle, up to the top, and back in the middle. There we go. All right, next one, we want to identify the same stuff and graph yet again. All right, our amplitude here is 5. We've got a flip going on, so it's going to be an upside down sine function. My b value is technically a 1, so the period is just 2 pi. I could do 2 pi divided by 1, but it's still just 2 pi. The interval would be 2 pi divided by 4, because we have 4 increments. So that's pi over 2. And then my shift is up 1. I'll start off by setting up my y-axis. My midline matches the shift, so the midline is y equals 1. From there I go up 5, because that's the amplitude, and I go down 5, because that's the amplitude. So that puts me at 6 up top and at -4 down to the bottom. Now that I have my y-axis set up, I can figure out where my x-axis would go. It's definitely going to be between a positive and a negative value. My guess is somewhere around here-ish. There's my x-axis. To label up the x-axis, we'll put our period value at the end, 2 pi. Then we'll chop that in half and chop each half in half. Our intervals that we're counting by are pi halves. So 1 pi over 2, 2 pi over 2, 3 pi over 2. 2 pi over 2, that reduces down to just plain old pi. Now I'll sketch in my little boundaries. So I have a little bit of framework. And just like before, I'm going to match this shape to this frame. So we start at the middle, which means we end on the middle. Then we go down to the bottom, back to the middle, up to the top, end at the middle. There we go. All right, now let's go backwards. Let's start with a graph and figure out what function creates that. So let's start with a picture of the graph and then write the function for it. When we do this, we're going to have to isolate part of it. So typically, I like to draw a little box around the part that I care about. Then we can find the midline to get our d value. Once you know the midline, you can count up to the amplitude to get your a value. The hardest part is going to be number 5 here, is calculating the b value. And we have to remember that our b value helps us find the period. So if I know the period is 2 pi divided by b, I could also make the same statement that b is equal to 2 pi divided by the period. These two equations are equivalent. Essentially, I just flippity-flopped the period and the b, which is mathematically legal. If you need a quick example as to how and why that works, 2 is the same as 10 divided by 5, which then indicates 5 must be the same as 10 divided by 2. Huzzah. Okay. Let's see an example. If I wanted to figure out one single iteration of this, first thing I like to do is figure out the highest point it reaches, figure out the lowest point it reaches. And then I'm going to look for a repeated pattern. So it looks like if I kind of traced along there, that would be one repeated pattern. So I'm going to go ahead and box that up. Once I have my box drawn out, I can find the midline relatively easily. And that's going to tell me the d value. So in this case, my d value is going to be 3, because my midline was y equals 3. From the midline to the top, or the midline to the bottom, however you want to think of it, that's going to be my amplitude. In this case, it's going to be 2. So the amplitude was 2. That tells me my a value. The b value is the trickiest part. The b value comes from the period. So the b value is going to be 2 pi divided by the period. Well, the period in this case is also 2 pi. So 2 pi divided by 2 pi, our b value is a 1. So my function is going to be 2 times either sine or cosine, 1x plus 3. To figure out sine versus cosine, I look at the shape. Kind of looks like an S. That's going to be a sine. So 2 times sine of 1x plus 3. Few things. No, you do not need the parentheses. And also, no, you do not need to write that number 1. Let's take another look. All right, we want to find one cycle of this graph. By the way, I should make note, in this class, we're always going to start from the y-axis because we're not shifting things left and right. Yes, you could shift things left and right. We don't worry about that in here, though. So if I go through one cycle on this graph, I can start from the y-intercept, keep going around until I wind back at that spot. So the part of the graph that I care about is this portion right here. My midline is going to be -1. That's the d value. My amplitude is how far up do I go or how far down do I go to get to the min, get to the max, respectively. In this case, that would be 3. And my b value comes from the period. In this case, the period was pi. So the period is pi. So I can do 2 pi divided by the period. 2 pi divided by pi. My b value is 2. This graph is a positive sine function. So my function rule is a, 3, times sine of bx, 2x, plus d, so plus a -1, minus 1. All right, last and final graph here. I'm going to trace one iteration. So we'll start from the y-axis and go all the way through one complete cycle. And I like to visualize kind of a little box just around that. And that's an indication that this is the only part of the function that I really care about. It's almost as if I'm kind of copy-pasting just that part to focus in on. All right. Let's see. I can figure out the midline. Smack dab in the middle here. It looks like we have y equals 0, so that's going to be the d value. My amplitude, how far up or down do I go? That appears to be 3. That's the a value. My b value comes from the period. So 2 pi divided by the period, which is pi, in this case is 2. Now this function is a negative cosine graph. So the function rule would be a -3 times cosine of 2x plus 0. And no, you do not need the plus 0 there if you don't want it. So if it makes you happier to leave that off, then leave it off. All right, that's it. That's all. You know the drill. If you have any questions, please let me know. And as always, folks, good luck. Have fun. Be safe. Roll Tide.